Hi everyone, this is your instructor Matt Denny, and if you're watching this video, you're probably interested in learning how to collect and manipulate data in order to discover something about the social world, to do some sort of social science research. It would be convenient if a push-button program like Microsoft Excel could give you access to all of the functionality you might need to do this. But unfortunately, in reality, it just can't. If you learn how to use a more full-function statistical programming language like R, you can collect, manipulate, and manage all sorts of different types of data. But why put in the effort? Well, for empirically oriented social scientists, the answer is simple. The new and exciting sources of data on social phenomena are increasingly coming from electronic sources in formats such as text, networks, and spatial data. And you need the programming firepower provided by R or a similar language in order to collect and work with these new data sources. If you're not sure if learning R will be beneficial to your research, this webinar will hopefully give you some additional context for how it might benefit, how you might benefit from learning and using R for social science data management. To start, I'll talk a little bit about how I got into using R and managing data. So my first experience with R was actually in a social network analysis class I took while at UMass Amherst as an undergrad. I was drawn to the class because I was interested in social network theory, but we ended up needing to use R for our homework assignments, as R has really good libraries for social network analysis. I didn't really get why I was learning all of this programming. The professor really sort of stressed this, and I already knew a bit of SAS and Stata, which are two sort of more standard social science data analysis programs, until we had to pick up a replication project for our final paper. I found a fascinating paper about the coevolution of homophily, so this is this concept of birds of a feather flock together, and cultural groups that I wanted to replicate, but it required that I run a pretty complicated simulation. Stata, SAS, Excel were really not so great for this, so it was time to put those R skills to use. I used a list of matrices to represent changes in the network over time, and some for loops to run my simulation quickly, both of which are concepts you'll learn about in the first few weeks of this course. And just like that, I was able to replicate the paper. One of the key advantages I got from using R was that I could represent many data objects, so think spreadsheets or matrices or vectors, again these are concepts we'll cover in the course, all at once in the same R session, and use them sort of together in conjunction to solve my simulation challenge, the thing that I was working with. And moreover, I was able to work with different kinds of data, so things like networks, than I had previously been able to represent in software packages like Stata. Over the years, I've branched out further into different kinds of data that are not easily represented and work with using something like Excel. And these days, I primarily work with network data, again, which can be represented as a matrix, but sometimes as a list of pairwise ties between individuals, and also text data. The beauty of R is that it provides a general enough framework, a general enough programming language, that I can use it to work with all these different types of data, along with more traditional spreadsheet data, and even combine them without having to resort to using multiple different platforms, having multiple different programs open at once. Another real advantage of using R is that it is increasingly being adopted by social scientists as a way to disseminate replication materials. A standard practice at most reputable empirical journals in my field, which is political science, is to require that authors post replication materials on a public site such as Harvard's Dataverse website once their paper is published. In most cases, these will consist of some data files and some R scripts that were used to perform the analysis. If you know how to use R and understand the R scripts, then you can easily replicate or extend someone else's analysis, which is a big bonus. Now, it is important to note that there are other general purpose programming languages out there, such as Python or Julia, which might be some of the ones you might have heard of. If your community uses Python more than R, you may actually get some benefit from focusing on learning Python instead. a really good idea is to ask some of the senior folks in your field what they use for data management or data analysis, and ask them, what language do you think I should learn? And that can kind of give you a hint or a signal about a good direction to take with your data management education. However, even if they say they use Python, for example, you can still benefit from learning R. So I picked up Python. I would say I'm a pretty proficient Python user in just a couple of weeks after using R for a few years. And at the end of the day, they're reasonably similar enough that you can transfer much of what you learn in this course to using Python. But the bigger point is that using a powerful programming language like R will allow you lots of room to grow as a data analyst. I hope this gives you some motivation to consider learning R. So in this training session, you'll get access to one of the screencast lectures I recorded for the beginning of practical data management with R. And we're going to start out by simply trying some commands in the R console and learning how to sort of use R as a big calculator. This video lecture is indicative of my approach to teaching about R, as I will make sure I really build you up from the basics, not assume that you have any previous programming experience, and try to give you enough context for the commands that I am teaching you that you can apply them outside of sort of the narrow context of the lecture that I'm giving. So with that, let's dive in, and I'll see you in this first lecture.
Hi everyone, this is your instructor Matt Denny, and welcome to this lecture on variables, comments, and math in R. So in this lecture, we're finally going to get into using R itself, entering commands and getting results. And we're going to start by using R as a big dumb calculator. I'm going to go over some basic math operators that you can use in R, and you'll sort of be sitting there saying, well, if this is what we're using R for, I could have just used the basic calculator app that comes with my computer. But obviously, we can do so much more in R than you can do in your calculator, and that's what we're going to start to get into. So the next, and perhaps the most key thing that sort of separates R from a lot of other programs you may have used, unless you've used full-functioning programming languages, is your ability to define variables in R. In other words, you can give a name or a symbol that can represent all sorts of different kinds of data. In our case, we're just going to be dealing with the most simple kinds, so either vectors, so that's a whole bunch of numbers contained in one object, in one variable, or single values like my cat or the number 24. And then we're also going to touch on a number of sort of practical things like commenting your R scripts, setting your working directory, and removing variables, cleaning up after yourself. So with that, I'm going to head over to my desktop, and I'm going to open up RStudio, and we're going to get started. Okay, so I'm on my desktop, and I've placed the basic R programming script. So you can tell that it's an R script here. It's over in the upper right-hand corner of my screen. The basic R programming.r file. So any file that has a .R as the file ending on it, that is an R script file. And so what this is going to do is this is going to contain all of the R commands that I'm going to be using in this tutorial, in this lecture, and all of the other lectures that have to do with this topic, basic R programming. So what I'm going to do is I'm going to show you how I would open up this script in RStudio. The basic idea is you navigate with an open window just like you would on any other program, and you find the .r file and you open it up in RStudio. So I'm going to go ahead, I'm going to open up RStudio. It'll just take a second here to load up. Okay, so we've got RStudio loaded up, and I'm going to click on the File menu and then select Open File. So this is how we open a file. It's sort of a standard way. We could also click up here in the top left corner. There's a little file folder with a little green arrow in it. You could also click Open Files there. And this, I'm going to navigate to my desktop and click on the basic R programming.r script. And so what we see pop up now in our editor window, on our source window, is this basic R programming.r script. So this is the file that I'm be working off of. I suggest that you follow along on your own computer. You can periodically pause the video, or if you've got a sweet double monitor setup, you can see what I'm doing and then also try it in RStudio. You could also just make the video smaller and listen to me as we talk through things. But the idea is that I'm going to give you context for this R script, and then I would really suggest that you actually try this out for yourself. Okay, so the first thing you're going to notice is that some of this text is kind of a green, a light green, and then some of it is blue, and there's even some of it that's gray. And so all the stuff in green, these are comments. What that means is they are bits of text, bits of code that if you enter them into the R console, nothing will happen. So for example, if I were to copy and then paste this little snippet called commenting into the R console and hit enter, what you'll see happen is nothing, essentially. So what has happened is that R will just literally print that stuff out to the screen, and that's it. And the way that we comment things is we use the hashtag symbol at the beginning of a line. So this is a really, really important thing that you should be doing. So in my view, you should be writing a lot more comments, especially as you get started with R programming. My view is you should be writing about 50 to 80% comments and only 20 to 50% R code. So the idea with comments is that you can write stuff down that won't actually be run in your analysis, in your data management task, and you can give yourself English comments that say, that you remind yourself, hey, this is what I did here. So for example, we're going to get into the first kind of thing you can do, so basic math. So for example, we can do addition in R. And so what I've done here on lines 17 and 18 is I have a little hashtag addition. So I'm letting myself know that addition is what we're going to be covering on the line below. It's sort of like a little note to myself. And I really suggest that you use comments very liberally. Just for every line of R code you write a comment to yourself that says, this is what I was doing here. So let's get into basic math by way of example. So again, there's a lot of basic math that you can do in R. So you can do addition. So that's 129 with the plus symbol, 3,483. So R will sort of work just like a normal calculator. It'll do the same thing for subtraction, multiplication, and division. So let's enter these in. What I'm going to do now is I'm going to highlight all of them, and then I'm going to click the little run button up here, and that's going to automatically transfer over all these lines of code from my R script file into the R console. So again, one of the things I could have done is I could be typing in here, 129 plus 3,483 and hitting enter. I get the same results. But this is not a reproducible way to use R. So the way you should be thinking about R is that you want to write a script file, which is going to live over here. This is static. It's like a text file. It's like a Word document. It's something that you can save on your computer and call it up later that will store all of the commands that you're going to use so that you can make anything that you're doing reproducible, and so that you can adapt that code. So many times I'll take code that I wrote in one R script and I'll use it in another R script, and that will allow me to then if I'm doing a similar data management task, or I remember, in this paper I wrote a couple years ago, I made that cool graph. What was the R code I used for that? I'll go and I'll take that R code. So you should always, always, always be writing any R commands, writing anything that you want R to do in a script file, and then saving that, and then entering that stuff from the script file into the R console. And again, we can do that using the little run button here. So this is just run all of these lines of code. So subtraction, multiplication, and division. All the stuff in purple is the R code that we actually entered in. And then the stuff where we see a little 1 and then in black the number, that's actually the result that R is returning to us. In addition to clicking this little run button, I could also, again, I could copy and paste. So I'll do Control-C or Command-C depending on if you're on a Mac, and then Control-C or Command-V to paste this in. So I can run code that way. I can also, one of the best keyboard shortcuts available in RStudio is, so if you're on Windows, if you hold down Control and then hit Enter when you've highlighted some text, then that will automatically enter it into the console. And same thing with Mac, except you'll need to do the command key. So I'm going to hold down command and then enter, and it's gonna automatically take all that R code that I had entered there, and it's going to enter it into the R console. So super, super, super helpful. All right, so a couple of other sort of basic math operators. Ruh-roh, we've made my computer mad. Alrighty. Ooh, is it going to define something for me? Apparently not. All right, go away. Well, the other things we can do, so we can try exponents. So that's just the caret symbol. So I'm going to run that. So exponents are also easy. You don't have to do any weird functions there. It's just some number, caret to some other number. And we can do logarithms. So these are logarithms by default in base E. And we're going to talk through in a later lecture how you'd actually get help trying to understand the log function if you wanted to take a logarithm, as you can see down here, in base 10 or log base 2. I'll navigate away from that for now. So we can also do logarithms. Again, useful little math operators. So this is all fine and good. We've used R as a basic calculator, and you can go online, and there are tons and tons of resources for how to do other fancier math. I'll also get later into the libraries that you can use to do fancier math in R. But let's get into the places where R really shines. So what we've been doing here is we've been using actual numbers, and we've been doing math with numbers. So 51 divided by 3 is 17. One of the things that sort of separates R from a lot of other languages or programs we may have used is that you can define variables. So the basic idea with defining a variable is that we're going to give a name to something. We're going to call it my value or my variable. You know, you could call it anything you want. My cat. The only requirements here are that in the name that you use, you cannot have spaces in that name. So I could not have something like my space value. R will throw an error if I try and create a variable that way. And you can also only have letters, numbers, and periods or underscores in your variable names. So you could have something like my dot value or my underscore value. Some people use something called camel case, so they'll uppercase every first letter in each word, and then they'll just sort of smush everything together. I've even done the combo underscore and camel case. So you could do something like this, my value. But however you want to name things, again, I would actually, my personal preferences, which I hold very strongly, are that you should use underscore separation. I think they're just easier to read variable names, and you should use very, very descriptive variable names. So you want to say what this thing is. So in this case, we're just doing an example. So what we're going to do is we're going to store the number 24 in the variable called my value. And to do that, we're going to use the assignment operator, which is a little left-facing arrow. So what is that? The left caret and then the minus sign. And so we can do this. So what I'm going to do is I'm going to enter in this. Run this code, line 40. And again, here's where having the line numbers in RStudio is super, super helpful. So I'm going to run line 40. I'm going to click run. And what it's going to do, we're going to see up here in my environment pane, is that we're going to now have something called my value, and it's going to store the value 24. So this is really neat, and the reason this is really neat is because now if I want to do math with my value, I can do things like my value divided by 4. And that'll give me back 6. So this is a really cool way. It's a way to symbolically store information in R. And then what I could do is I could also change this value of my value. So I could also do something like my value. Now here's, I mentioned in a previous video that we've turned on code completion. So when I start typing this in, RStudio is going to say, hey, you've only got one variable defined and it's called my value. Maybe you wanted to enter that. And if I click here, it'll actually automatically complete that for me. So I could, instead of having my value be equal to 24, I could have it be equal to 35. And then we can see down here in the environment pane that I've actually changed the value of my value from 24 to 35. So again, this is a really critical concept. You can give this thing any name you want, and then you can put anything you want associated with or stored in the little box that my value is holding. So I think that's actually a really useful way to think about variables at their most basic level. Is it's a little box and it says you can put stuff in there. So you could put in numbers. We're going to learn about putting in text. So I could do something like my value equals cat, and then it will change it to cat. Whatever the case may be, it's a box and it'll store stuff for us. And this is a ridiculously powerful concept. So taking one step further up, so we talked about, right now we're storing individual numbers or maybe individual strings. There's the next step, more complicated data structure in R, is something called a vector. So this allows you to put together a bunch of numbers, glue them together into one package that's all stored and all accessed by one variable name. So the way we do that is with the C operator, the concatenation operator. So the way this works is we say C, and then we use open and close parentheses, and inside of there we can have any number of numbers, and as we'll learn later, strings or other things like that, as long as they're separated by commas. So you have one thing and then each thing is separated by a comma. And if we enter this in here, if we run this line of code, what we'll see is that we've created something called myVector, which is something of class numeric. Again, we'll go over this in the next lecture, but it's something of class numeric. And it contains the values 5, 34, 76, and 13, which we can see are the things that we put in myVector. So the idea here is now, instead of having to maybe keep track, maybe these are the ages of your family members or something like that. Instead of having to keep track of them separately or remember them just as numbers, you can actually store them all in one variable. So this variable now holds these 4 different numbers, and as we're going to learn, you can actually access these 4 different numbers in a lot of different ways. So vectors and just basic values that only contain one slot, are going to be hugely valuable to us. I don't know if the wheels are turning for you quite yet, but there are just so many things we can do even with these 2 basic data structures. We could, for example, create a vector, and these vectors can be long. In fact, in R right now, you're limited to a vector length of about 2.2 billion. So we could, for example, store the names of every person in the United States or something like that in a vector. So these are really powerful objects, and that would all be represented in R as just one variable, one thing that we could then go and access. But before we start getting into that, this topic is sort of a lot about a lot of basics that you're going to need as we get into working with these data structures, things like vectors, and later we'll learn about matrices and other things like that. And so a couple of these things are really, really important. So we've created 2 variables. Okay, and right now we want to use them because we're sort of playing around with R in our studio, but let's imagine we wanted to get rid of them. So to get rid of a variable, we can use the rm function. So this is the first time we're encountering functions. So the way the rm function works is I can say rm, and then in little parentheses, and then I can give it something that I want to remove. So it stands for remove. So if I type in my, and then my value, let's remove my value, I can hit enter here, and what will happen is we can see that in our environment, my value went away. So if I try and access my value, so the way that we would access my value in R is we would paste it into the console and then hit enter, and what we'll see, we'll get an error. This is our first error. Error, object my value not found. So in other words, we removed my value. Now we can create it again. I'm going to enter here again, and I'm going to create it again, and then we can remove it. And so, whoops, let's go up one, and we're going to remove it. Another thing that I'm doing here that's kind of handy, I'm using the up and down arrows. So if you use the up arrow when you're in the console, when your cursor is blinking in the console, you can re-access old lines of code that you've already entered. This is super, super helpful. So for example, I can do something like call my value again. Oh, it's not there. All right, I can now scroll up. I can create my value again. I can see that it has a value of 24, and then I can remove it. So this can also be a really helpful way to sort of jog back if you're entering in commands a lot for some reason. Okay, but let's create it. Now imagine we wanted to clean everything out. Imagine we wanted to get rid of everything. And I think this is, and I'll submit to you that this is a really good idea to do at the beginning of every R session. In general, you want to start an R session, you want to start some project or something that you're doing with a clean slate. You don't want anything in your environment. And so one way to ensure that is to run this rm, and then it'll have an argument list equals ls. So rm, you can either give it just the name of a variable without any quotes or anything, or you can give it something called list, and list will contain the names of the various variables that you'd like to remove. So if I just were to run this ls function, so I'm just going to run this in my console here, what I'm going to get is ls is going to return to me as a character vector, as a vector of character values, the names of all the variables that I've created. So I have two variables right now that are alive, that are available to me. One's called my value and one's called my vector. And so what I'm telling rm list equals ls is I'm saying to the ls function, go and find me all of the variables that I have currently created that are currently in my environment, and then list them for me. And then the rm function is saying, I'm going to eat all of these variables. So if I run this whole line of code now, I'm going to run it. What's going to happen is we're going to see the environment is empty. In other words, we've gotten rid of my vector and my value. So this is a hugely important thing, is to be able to clean stuff up. This can also be useful down the line for freeing up memory, or just keeping clutter to a minimum, is getting rid of variables when you don't need them anymore. Okay, one last thing that we're going to cover in this lecture is setting your working directory. So I mentioned this before, but your working directory is where R will go by default to look for files when you're reading them in, and also to save files when you're saving them out of your R session. And so there are two ways to do this, and I would suggest when you're getting started, you take the simple point and click option to begin with. So the way to do that is you go to the session menu, and then you click Set Working Directory, and it'll give you three options. It'll say to source file location. So if I do that, it will set the working directory to the folder that contains the file I was working on. So for example, if I do that right now, I'll click that. What's going to happen is it's actually going to generate R code. It's going to set it to my desktop. Now, if you're on a Mac, your computer your set working directory statement might look similar to mine. If you're on a PC, it's probably going to have some C's and colons and backslashes and stuff. But again, what we've done here is we're using a function. So I'm gonna cover more of what functions are. But for right now, you can think about it as it's something that's special, that's set aside in R, that will perform some task for you. So the setwd, the set working directory function, inside of these parentheses, we give it a string, and that string is a file path. It's a path to a folder on our computer. Just like with rm, we gave it a variable that we wanted to get rid of. Here we're giving it a string, and we're saying I want you to set my working directory there. So you can either choose session set working directory to source file location. You can also just choose a directory. So I could choose a directory. I could set it to my Dropbox folder, or my documents folder, or in this case, my desktop folder, right? Anywhere I want, and then I'd click open, and it will automatically generate that code. And so if you're following along here, what you could do is you could take this and you could copy and paste the set working directory code that comes out of doing this using the point and click option. You can copy and paste it into line 62 of this R script, so that you could have the set working directory code work for your computer, because this is set up for my computer. You may not have something called a desktop. You may not be using a Mac, and so you may not. This may not run for you. So anyhow, what we've done here, so we've introduced a couple things. We've introduced the idea that you can use R as a calculator. As you've noticed, all of the comments here, this is just me telling you stuff that I've been telling you in this lecture, so you can come back and reread this stuff. And I've included it all as comments. Again, another point here, so remember this little line, this little gray line? I've tried not to go over that, so I'm trying to follow the R style guidelines and only make lines of code or comments that are 80 characters wide. So I have these big blocks of comments here. I just keep hitting enter and putting in a new hashtag here to say this is one big comment. And then I've got a lot of comment for a little R code. So again, we've gone over using R as a calculator, this idea that we can create variables that can store stuff for us, and then some preliminary stuff like getting rid of variables and setting our working directory. And these are sort of some of the basic tools that we're then going to sort of build on as we go through these lectures. Everything we're doing is sort of meant to build one on top of another. And these are some of the most fundamental things that you're going to be doing all the time in R. Is using it to create variables, and then you're always going to be moving around. Where's your working directory? Am I getting rid of stuff? Am I creating new variables? So again, thanks for watching this lecture, and I'll see you in the next one.